Good morning, everyone. Today we are going to discuss the remaining topics which are we covered in the previous session related to the multi-threading. Today we are continue with this and go some extend in the depth of the multi-threading concepts like synchronized locks and what are those things. This all. Next, first thing will be the first we will see the some methods. What are the built-in methods in the threads we contains? We already see some methods like a sleep, join, and all those methods. Again we discuss that, and after that we'll move to the race conditions and synchronize and all the things we covered a lot. We'll go one by one. First we'll see some what are the built-in methods we have. First thing we already seen that set name and get name. Okay, these are the two methods for setting the names to your threads and get the name of your thread. Set the name of your thread, get the name of your thread. Before going to that, one method is there. It was current thread. That means suppose you have a n number of threads. In that n number of threads you want to know which thread you are currently on that, then current thread is a method to know the on which thread currently you are. Okay, suppose on a 100 numbers of thread you want to be on one single one, then current thread is pointing to the which thread you are currently executing. That is the thing. And set name and get name. Normally set name and get name, suppose we'll go with the example. mm, Simply uh, simply class, my class name will be the, suppose my thread is my class, it was extends from the thread. This is one way of thread creation, right? In this one way of thread creation, suppose I want to set the name to my thread, then how can I set a name to my thread is by using the constructor. By using the constructor, because normally if you are setting the thread names means thread contains the one method to set the name, then only it can able to set the name, right? Like the same way, this is one way of creation of the set. Suppose instead of this, if you are go with the implements, or else suppose first we'll go with the, okay, first we'll check with this thread, normal thread. Suppose we have this name, then suppose you want to set a name to the thread. How can you set a name? Suppose you are not setting any name, then suppose in this is out. Sorry, first you have to write a run method. Why? Because your thread will be start running from your run method. That is the case. So I'll mention here as at the rate override. Okay, in this run method I simply check the what is the my thread name. I want to check what is my thread name. So simply thread dot, then it will throw an error. Why? Because you are simply mention the thread, but it doesn't know which thread you are calling. That means you are intent to print the this thread name, right? But it doesn't know particularly which thread you are calling. For that, thread dot current thread. Suppose it is a normally current thread is trying to referring the which thread you are calling. That is the way. What is this error? Okay, small c. My thread name is small c. Okay, small c, capital E. The suppose that means you are creating here mainly there are the two threads. One was main thread, another one was my thread. There are the two threads you have. But if you are calling this get name thread dot get name, it doesn't know which thread you are calling. Because of that, you are using this current thread. That means you are referring to the which is the active thread you are currently executing. That is referring to that current thread usage for this only. That means you have a multiple threads, you have to refer for the one thread, then current thread is a method for that. Okay, this is the one way you have to check. This is the current thread method. What is the purpose of the current thread? Like the same way, okay, current thread dot get name. Fine. Once I'll run this, I'll try to check. Suppose my thread, I simply create an object m1 equals to new my thread of my thread m1 equals to new my thread of. You want to start the thread, right? M1 dot start. M1 dot start. Okay. I'll run this. It will simply print the thread 0. Thread 0 as a name to the thread, or else thread 1. Why? Because by default names it will take. By default name means it will be the thread 0, thread 1, thread 2, thread 3, thread 4. Like this, how many threads you are creating, like that it will allocating a names to that as a default name. It was the thread 0. Suppose you are creating another thread and try to get the name of the thread, it will be the thread 1. Next it will be the thread 2. Like that, based on the threads you are creating, it will be start from the 0 to n. Like that it will come. Suppose you want to set the names to your thread, then there is a way. Then there is a way of you can pass directly. That means by using the constructors also you can do, or else by using the set name and the get name also you can. Suppose by using the set name, then here you can set the names. Set name of set name accepts one value. Suppose my thread name is my thread. Okay, it will not returning anything. So because of that, it was setting the value na, so it will not return anything. So system.out.println not accepted. Here also you can check. Suppose if you are checking here, you are by using the exact thread you are calling, right? So because of that, m1 dot get name is enough. M1 dot get name is enough. Why? Because here you are referring the exact thread. This thread means all the threads included. Okay, this thread means all the threads included or the main thread. This m1 means you are particularly referring to the my thread. You are particularly referring to the my thread. So this is the one way. M1 dot get name. So I can print it now. This out. This is the way you can set the names, or else here only you can m1 dot set name. Here also you can set m1 dot set name, but where you are using the method name depends on that the allocation will be different. Suppose in the class itself you have to creating then thread dot current thread. Why? Because there it will be the chance to you are talking about the multiple threads, but here you are calling the exact thread name, right? So because of that, simply m1 dot get name. I'll check it. Now it has to be print my thread. Why? Because I am changing the thread name to my thread from thread 0 to. Wait a minute. Hmm. Hmm. Again it will throw a thread 0. Why? Because if you observe here, I am setting the thread dot current thread. Thread dot current thread. It was till to this only. That means it will be changed. Suppose it means it will be the not at all any constant name for the entire execution. That means it will be changes. Suppose instead of this, instead of this, I can simply my thread. Here what will be happens is it will be set the current thread, right? So then for every thread, that means if you are going to the another thread also, it will be the name for the only to the class level. Only to the class level the thread name will be the my thread. Outside the class level it will be changed. This is the way you can set the threads in the class levels and in the global level. By the global level, using the object reference, you can set it. We are seeing the different types of thread creation, right? You can go with the any other, and also in the constructor also you can pass. In the constructor, how you can pass is simply simply we already know that, right? Suppose I'll go with the lambda function thread t1 equals to new thread of. This is the way you can calling that lambda function, right? So lambda in this mm, this entire thing. Suppose sys out this is thread. I'll writing one empty statement here. We are calling it as a constructor normally, so you can allocate a name here. My name will be the thread. Okay, simply what I can do is sys out sys out of even dot get name. This is we are passing through the constructor. Suppose if you are using the implements instead of this here, Instead of extends, I can use the implements runnable. Implements runnable. In this runnable, what I have to do, you can create a object for the my thread, and you have to be pass into the this thread, right? The same way, the same way. Simply in the time of here, you can pass the value. My value will be the, suppose thread 1 is the name. So or else simply you can do one thing here in the thread m1 itself, or else m2, here new thread of, in this thread you are passing the, what it is, object, right? In the object you are allocating the name for that thread. My thread will be the thread 1, suppose. That means in the thread, actually thread contains the set method. So for the thread you have to pass the value which you have to be set. So you can simply print that m2 dot get name, then check it. Normally he, by using the set name also you can set the names, but it is the other way. You can set the names by using the m2 dot functions. That means in the constructors you can pass thread 1, right? This is the way. There are multiple ways to get it. Okay, this is the current thread method, and the set name and the get name. Set name for setting is the name for your thread, and get name is getting the name of your current thread. Next things, we already discussed that sleep, right? Sleep already we discussed. Join is also discussed. Next, fifth one, set priority and get priority. Okay, set priority and get priority. Set priority is nothing but you are prioritize your task. That means if you have any knowledge regarding the OS, in the OS at the time of the academics or all the things, they are introducing one topic of CPU scheduling. CPU scheduling. In the CPU scheduling, they are said like allocating some space or some time for the done the task. Like that, you are giving the priority for the task to done. All the tasks can be done, but the you are intimate to your scheduler which task you have to be done first, which has to be done next, and it has to be done after that. But you are just intimating to your scheduler, but it obeys or not, it will be the, it depends. Suppose scheduler has no time to that, then it will not intimate that, it will execute in a random way. But you are intimating to your scheduler, that is the way. Set priorities and the get priority. You have to know the priority which you are set for your thread, that will be the get priority. You have to know the setting the priority of your thread. Suppose I am taking the lambda examples. Why? Because instead of creating every time I am class, simply go with that. Simply suppose thread t1 equals to new thread of, in this new thread I am using the simply callback, my callback function of sys out of thread 1. Okay, thread 1 executing, or suppose like that. Okay, the same way it will be the T2 and it will be the T3, and here I can place the T2 and the T3. Before getting the priorities to set, default priority it will maintain as a normalized. Normally there are the three types of priorities in general. You can assign with the values also. Normally in general priorities are three. One was max priority, next one min priority. Max priority value is 10. Maximum priority you can allocate for a thread is 10. That means it will be the high priority. If you are allocating any thread with a 10 value, then it will be a high priority of first it has to be executed. Second, min priority. The min priority value is 1. Okay, if you are 1. Next, norm priority. Non priority is 5. By default all threads can be with a priority of non priority. If we can check now, then suppose sysout of t1 dot get priority. These are all the methods only. We already seen that get state, right? T1 dot get priority, but we have to start the threads now, or else simply once I'll try to run it, maybe it will be print. We'll check it. 5, but I am not allocating any priority to that. Why? Because it will take the default priority of normalized. Norm priority it will take it as a default nature. So because of that, if you want to allocate the priorities to your threads, then set priority is the method. T1 dot set priority. T1 dot set priority of, suppose my set priority value always lies between 1 to 10, or else you can use the three keywords like that. Suppose you can use the max priority. Okay, suppose you can directly assign with a 1. Sorry, get priority now. So T1 dot set priority of 1, the same way T2 dot set priority T1 dot set priority of 5, then T3 dot set priority of 10. Then if you observe T1 dot start the same way T2 dot start, that means you are starting the all the threads, then you have to be execute the some things, right? t3 dot start. Start is the method to run, right? First it will print the thread 2, thread 3 and thread 1, but I am allocating thread 2 with a what it is normalized priority. First I am giving the priority to the thread 3, but it will execute the thread 2. Why? Because your scheduler not maintaining that. But suppose, but low priority always will be at the last. This norm and the set priority values can be will be the nearest. So it will be priorities the T2 and the T3 as well. But low priorities always will be the low priority. Suppose what you have to remember here is first thing, always set priorities values lies between 1 to 10. Beyond the any value you can try to give, it will throws an error. Why? Because set priority values lies between the only 1 to 10. Okay. Why? Because maximum priority is 10. The maximum priority 10 means it will be the high chance of priority. Suppose you want to give any high priority to a thread, then set the value as a 10. Okay. This is the priorities. Set the priorities and the get the priorities. Get priority you can use simply like this. Set priority like this. Values you have to pass, integer values you have to pass. That integer value must lies between lies between 1 to 10. I'll show that. Suppose if I'll try to give the here 20, it will throw an exception of illegal argument exception. Illegal argument exception, that means your value needs to be from 1 to 10, but you are providing the value of 20. That is the issue. So you can simply pass to thread 3, thread 1, thread 2. Okay. That means sometimes set priority of 1 and set priority 2 will be the same. Why? Because scheduler your CPU depends on your CPU, it will allocating the schedule time to that. Okay. That is the chance simply. But a high priority compared to the 2 and 5, thread 3, thread 3, this is the way. Okay. Suppose uh, these are the 6 methods, and after that we already seen the seventh one, get state, right? Get state method. Get state method is helps to know the which state of your current state of your thread, like a new and all the things. And get id is also one method. This get id method is nothing but every thread is with one id, unique id. It will be written that. Okay. These are the some basic methods. These are enough. We'll move with the next thing of another thing. It was a race condition. The major loophole or the drawback with the multi-threading is this one. In the my new class, race condition. First you have to understand the what is the race condition. First, what is a race condition? Then two or more thread try to access the shared data or shared resource. Shared resource at a simultaneously or simultaneously. Simply two or more threads, try to access the some shared data of the all threads at a moment, then there is a chance for the race condition. We already discussed that, right? That means suppose imagine a thing, one bank account, suppose one bank account have the 2000 rupees of money. Two persons go to the different ATMs, they are trying to withdraw the 2000 from the same bank account. They two members can observe the balance as a 2000 only. Why? Because these two are independent tasks, right? So it will be seen that only 2000 will appear to them. By using that, they are perform on the withdrawal function. By performing the withdrawal function, but one will be the success, one will be becomes a minus thing. This will comes under a trace condition. Why? Because two threads try to access the same account balance, right? Same account balance. If both the methods will be occur at a moment, then there might be a chance for the improper results. That is the race condition. We'll check the same thing with the, okay, suppose in the same way, suppose class, my class name is suppose bank account. I'll do one thing. Okay, my class is bank account. Suppose I have a method of public int my balance. Suppose balance equals to 3000 rupees. Okay, suppose my balance is 3000 rupees. Public, and create a withdraw method. Public void withdraw. In that withdraw method, I am passing the amount to withdraw. Int, okay, int my amount of withdrawal. Hmm. Okay. Suppose amount to withdrawal. In the amount to withdrawal, if when can I withdraw the money? Suppose if balance, if I am not maintaining any minimum balance also, how much I can withdraw? Suppose my amount is lesser than the balance, I can withdraw. Suppose if I try to withdraw the 1000, it will gives the money, right? If I'll try to withdraw the amount of 1000 rupees, it will access. That means whatever the amount lesser than my balance, whatever the amount lesser than my balance, I can allow to withdraw. So if balance less than suppose amount, if my balance is less than the amount, then I can simply, what you have to do, you have to decrease the balance. How much? Suppose I can print simply sys out of withdraw success. Okay, withdraw success, else sys out insufficient balance, right? The same way, if withdrawal was success, you have to decrease the balance amount, right? So balance minus equals to AMT. Okay, this means simply balance equal to balance minus AMT. I am updating the balance. Okay, this is fine. Okay, okay, all good. Okay, now I am making this into a thread and I have to pass the amount to that withdrawal method. uh, okay, okay, i'll make I will make this into a thread. I will make this into a thread and simply uh, I'll do one thing. After execution of this balance, I'll print that balance, right? Sys out of balance amount, sys out of balance amount plus balance, right? My balance amount is balance. Then simply what you have to do, you can create a threads t1. Wait a minute. Suppose I am creating a thread, right? Thread t1 equals to new thread of, this is the way. Okay, 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 okay. What is my name? Bank account, right? So control C. It already extends from the thread. Bank account equals to new bank account of, bank account equals to new bank account of. Then you can simply start t1 dot start, right? But you have to pass the money. We'll do one thing. We are not writing the any run method, right? So I'll go with a different approach. Why? Because I am not writing any run method there. That's the issue to me. Here I am not writing any run method. So I'll do one thing. I'll make this as a only bank account class. Simply I can do one thing. Okay. Simply thread. First I'll create an object for my bank account. Bank account. Suppose ACC equals to new bank account of. Okay, this is my bank account. For this bank account I'll do one thing. Thread t1 equals to new thread of. In this new thread of, I'll use the callback function. Okay, I'll use the callback function. In that callback function, I'll simply acc dot, my acc is the bank account, right? So acc dot uh, withdraw. ACC dot withdraw of my money is suppose what the value I initialize 3000, right? So I'll go with the 2000 comma, okay, 2000 only na. So statement and statement, right? And the same way another thread, control C, control V, T2, the same thing. ACC equals to withdraw of 2000. These are the two things I am doing, and I have to start the threads, right? So T1 dot start, T1 dot start, the same way T2 dot start, T1 dot start, and T2 dot start. T1 dot start and T2 dot start, and okay, now I can run. What it do? I'll write the different condition, huh? Balance greater than amount. If balance greater than amount, then withdrawal success for the both the threads. If you check the amount balance, one was 1000, one was the minus 1000. Balance could not be becomes minus, right? This is the race condition. Why it will happen? Because at the time of the start, both the methods can occur at the same moment. Okay, both the methods. What will be happen here is, firstly, imagine the thing. Suppose we'll do one thing. We have to check which user comes first, right? So string user, okay, user. In this user, I'll pass the ATM1 as a string. Here also ATM. MN. What happened? String capital S. Right, fine. And withdrawal success for the user. Then I can check which user comes first. One user will become, but balance amount after. I'll do one thing. Okay. Okay. If one user execute now, all the things it will be execute. So okay. Once I'll run this. Withdrawal success ATM1, withdrawal success ATM2. First withdrawal success ATM1. That means user ATM1 and ATM2 will be comes at a time into the withdraw method. So both the conditions will be true. That means for the checking of this condition, balance greater than the amount 2000. That means 3000 is greater than the 2000 for the both the threads. 3000 is greater than for the both the threads, but one will be committed first. In the two threads, one thread will be committed first. Suppose one will be updated the balance to the 1000, but this condition becomes true, right? So balance becomes 1000 here. Why? Because 3000 minus 2000, so 1000 becomes, so 1000 minus 2000, so it will become minus 1000. Why? Because this withdraw method accessed by the both the threads at a moment. Both the threads at a moment access it. So this condition will be true for that. This is the scenario of the race condition. The shared resource will be accessed by the two threads at a moment. Then it would lead to the inappropriate, that means inappropriate results. Inappropriate results. Okay, that is the fine. Now how can we achieve this race condition? First we have to understand what is the race condition. Race condition is simply two or more threads that try to access the shared resource at a moment simultaneously. Then there might be chances for the unexpected results. Okay, how can you achieve this is by using the unproprietary results occurs because of unsynchronized, non-synchronized. You have to make this as a synchronized. How to make this as a synchronized is by using the synchronized keyword. Synchronized is a keyword making or to avoid the resort. What that synchronized keyword actually do is suppose at a moment only one thread can access the method. Remaining method will be in the locked state. Okay, only one method can be executed. Remaining method will be in a locked state. I'll show that. Suppose in simply here you can maintain the synchronized. Okay, synchronized. If you observe, again I'll run this. Either ATM1 or ATM2. Okay, only one method or one thread can access the first thing. Suppose if you observe balance amount 1000, right? This synchronized keyword what it do is suppose imagine the thing ATM1 will be first comes to the withdrawal method, then it unlocks the this method to the ATM1 until until T1 completed or thread 1 completed for this method. This is not allowed to entering other threads. It will be in a lock. That means it locks the thread 2 here. Locks the thread 2. Okay, locks the thread 2 and when the completion of the one thread will be completed, then only allows the other thread. This is the synchronized. This synchronized also in a different ways. The synchronize also can be do in a three ways. One is simply it is we are calling it as a instance. We are calling it as a instance. Why we are calling it as a instance? Because suppose column. Hmm. కానీ ఒక 10 minutes. Okay, fine. Ah, this is the way you can synchronize. But in this also there is a synchronize also in a two ways. Normally in a three ways. One was synchronized instance method, one was synchronized block, one was synchronized class. What this all will see. In before we are going to that synchronized types, here only I'll discuss the one thing. One was wait and notify. Wait and notify. Wait and notify what it do is suppose one thread depends on a other thread. Imagine a thing. One thread depends on a other thread. Then you have to be intimate to the suppose here T1 and T2 are there, right? T1 and T2 are there. T1 or T2. One will be depend on other one. Then you have to intimate to T2, right? I am completed, you can come. That means you are using the wait and notify. Wait means you are maintaining one thread into the wait state. Intimate to the thread, you can continue. That means wait is for locking the thread, notify is for unlocking the thread. We'll see that. Before that, synchronized as a types. This is a instance method. Instance method. Why it is calling as an instance method? Because suppose if I taking the another bank account as an example, Control V. Suppose I am making it as a ACC1. I am making it as a ACC1. Then if you observe ACC1 dot withdraw. This ACC dot withdraw is different. ACC1 dot withdraw is different. If you are using at the method level, then it will be the instances synchronized type. Then for the different objects, for the different things, then it will not same. Then it is not same. That means this instance is different. This instance is different. You are synchronizing for the only one instance level. If you are doing like this by using synchronized, if you do like this, it was the one thing. Suppose you can do static here. I'll make this into the static. Why? Because static blocks only can allow the static elements. So static balance. So once I'll check this. The static things are class variables or the class methods. You have to observe the change now. It is a class static. That means class synchronized. Class synchronized. This and these are class synchronized. That means after completion of the one object instance only, it will go for the another instance. In before it was an instance. So every instance it will be the different. But here for all instances also it will be the same. Why? Because you are making it into a class. If when you are maintaining some things into a static, those are related to the class. Those are related to the class. So one instance completed only, you can go with the other thing. I hope you all observe the change. In before this instance and this instance, if you are not maintaining the static, then what it is? Suppose then it will not allow. It will allows the withdraw method for the ACC and ACC1. Why? Because these are the different instances. Now it will not allow that. Why? Because these are the class instances, right? So after completion of the one class instance only, it will come to the other class, right? These are not object instances, these are the class instances. So by using the class name only, you can access it. So for that, okay, right? This is one other type. We are discussing two things. One was the class level instance of the synchronized. Another one was the instance method. Okay. Next, suppose instead of maintaining synchronized for the entire method, you can maintain the synchronized for the some block of code. Some block of code. Suppose I am not intend to maintain this entire method into the synchronized thing. I'll maintain something into the synchronized. I'll show that. For that, I'll comment it. I'll remove the static and also the synchronized. If I remove the synchronized, means both the threads can be accessed at a moment, right? Both the threads can access at a moment. Simply I'll do one thing. Sys out of processing withdraw plus user. Okay, processing withdraw for the user. And what the things I have to make into the static? I have to make the static of this withdrawal section of the this entire part, right? This part only I have to make into the static. So I'll make the static block here. That means synchronized. Sorry, synchronized block level synchronization. Here you can pass the this. Why you are passing this is because of which current instance you are making it as a synchronized. that you have to be pass. Now you can check. Okay. Processing withdraw ATM1 and withdraw ATM2. That means both can be accessed the withdraw, but but withdrawal success only happens to the one person. That means you are particular some part of the code only you are maintaining it as a synchronized thing. Okay, these are the three ways of synchronization. One was for entire method you can synchronize, one with the all the instances also you can synchronize, one some part of the code you can synchronize. These are the three things we are go with the synchronization. And next we will go with the wait and the finish. Wait and notify. These are the two methods to implementing the things of suppose simply why we are using this wait and notify, because of T1 is depends on the T2, then you are intimating to the T2 I am completed, you can proceed. For maintaining one into the waiting, suppose you have to tell to wait and you have to notify to withdraw. How can you do this is suppose in the same example, wait and notify how can we achieve is simply in the withdraw and deposit. Suppose insufficient balance to withdraw, then you can tell to the person who are coming. Suppose ATM1 and ATM2 are the two persons you have. ATM1 and ATM2 are the two persons you have. In that scenario, ATM1 has the withdrawal success, ATM2 go with the insufficient balance, then you can tell to the ATM2 please wait till deposit will be occur. After deposit successful, you can notify to that user. You can notify to that user, your withdrawal will be now. You can check your withdraw. You can now check it. That you can tell. Mm. For that deposit and withdrawal, we will see. Mm, in the same scenario, of I'll make and one thing you have to be remember, when you are using the wait and notify, must you have to use the synchronized. In the synchronized only you have to use the wait and notify methods. Okay, fine, fine. Right. I'm not writing anything. Huh? Synchronize to avoid the synchronization. Synchronize to avoid the race condition. Simply race condition by maintaining locks. By maintain the locks. Okay, and types. First one synchronized instance. Next synchronized class. Next synchronized block. Okay, next we are going with the wait. Maintain wait method is helps to maintain a thread into the wait state. Maintain a thread into a wait state simply, or lock the thread, lock the thread. Notify, release the locked thread, release a locked thread. Okay, right, fine. Release a locked thread. These are the two things we have in the thing. Suppose if you want to use the things, suppose you want to use the wait conditions, conditions to use, conditions to use. First thing was, in the first thing, must use synchronized, must use synchronized. One was, okay. uh, Second also I'll tell, but before that I'll show and tell, right. Where is that this is the method, right? Hmm. Okay, fine, fine. Simply here is a balance and withdrawal amount on the string, but you have to use the wait method. That is the thing. For the wait method you are not allowed to use the if conditions. Must you have to use the while. Why? Because every time you have to check whether it was true or not, so you have to be loop it, not you have to check the if. So if and else is also not need. Why? Because we are not doing the else condition, right? Here our scenario is different. While balance amount you have to be decrement withdrawal success for the user and decrement. But you have to maintain the state, right? Wait, simply you are writing the wait, it will throw an error. Why? Because thread means it has to be completed with the milliseconds of time, but you are maintaining into the wait state in a idle position. So you have to be maintain the try and catch blocks. You are intentionally do it. For that, simply you can use the try in the try block. In the try block, you can simply use it, right? Try is always paired with the catch. So catch block of exception. Normally it was interrupt exception. Instead of that, I'll saying that exception. I don't know the which exception is exactly right? Because of that interrupt exception. Normally interrupt exception it will be raised. You can place it as a interrupt exception also. You have to remember, if you are position it to the wait position, then what will be the exception? It will be erases. Here you can tell that interrupt exception will be erases. Interrupt exception. Okay. Interrupt exception can be erased. Next, what will be the thing? Okay, fine. In the catch block, I am not writing anything. Wait state, I'll maintain it. Suppose if wait state is there, you have to be intimate the notify also, right? When you have to be release the wait state. That thing, that thing, how can you do is withdrawal method. Where is that withdrawal method? I can close it. Uh, in the withdrawal method, simply I can write public void deposit. One thing I have to mention what it is. Always you have to use it in a synchronized. So synchronized void, right? Simply like that. Uh, must use while condition, not if. Okay, not if condition. Or must you have to use while condition. And void deposit. Suppose deposit is my method. void deposit of. In the deposit also you have to pass the amount, right? Int amt, suppose balance plus equals to amt. That means deposit successful. I have one message I can print now. This out of deposit success, deposit success. Then you have to notify. This is the notify. Okay, and ATM1 and ATM2. These two threads are fine, but these thread 2 or thread 1, one will be in a wait state. Why? Because after withdrawal the balance, insufficient balance one can be happen. Why? Because I have the only 3000, so 2000 will become, yeah, the amount becomes the 1000. It will accepting for the deposit, so it will be in the wait state. So you have to be done the deposit, right? So for that, mm, do one thing. Thread deposit. Okay, thread deposit thread, suppose deposit thread is the thread, equals to new thread of, new thread of na, mm, simply simply but if deposit also, mm, we'll wait for some time, we'll wait for some time. That means I'll make the thread into the sleep, thread dot sleep of 2 seconds. My thread into the sleep mode for the 2 seconds. After the completion of the thread sleep into the 2 seconds, again I'll maintain the try catch. Okay, suppose surrounded with the try catch. Try catch interrupt exception, interrupted exception. Normally it was pin stack trace, already we discussed that. Here what you have to do, you have to call that acc dot deposit of amount, right? Amount, my amount is suppose 2000. Okay, 3000. Okay, my amount will becomes 3000. You have to start this deposit dot thread also, right? So deposit dot thread, deposit dot thread dot start. Fine, I'll check it, right? First my ATM1 or ATM2 one will be execute. It will be depends, not I'm sure that it will be the ATM2. First ATM2 will become, check, ATM2 withdrawal success, deposit success, exception in the thread 2. What that exception? Change lang illegal monitor status of notify, notify. Okay, illegal status of notify. Okay, I want to write something at the notify. Oh sorry, always you have to use synchronize. Illegal things, these are the illegal notify. Notify first ATM2 deposit success, withdrawal success for the ATM2. It will not print the balance amount. Okay, right. Why? Because na, okay, first ATM1, why Wait a minute. ATM1, ATM1, T1 dot start, T2 dot start. Okay, in the sleep mode of the thread, check it. Once again, I'll run this. Withdrawal success ATM1, balance amount 1000, deposit success, withdrawal success ATM1. Always you have to be done in a single thread. Why not in a, okay, fine. Hmm. Actually, only one thing it will become na. So synchronize interrupt exception. Normally this is the wait purpose. Suppose if it will become, then it will shows deposit success withdrawal balance. After that also it has to be show the balance na. So deposit start. I think we are missing something. Once we'll observe the output, or else T1 dot start and T2 dot start will be only run. Deposit success, balance amount 1000, deposit success, so withdrawal success ATM2. Again it will not print that balance amount. Why? Okay, normally this is the way you have to be check it. I'll print that this deposit method. After that balance will be updated or not. Once I'll check that. Okay, I'll do one thing. Sort of try to withdraw by user, try to withdraw by user, and sys out catch, sys out balance amount, this try catch, withdrawal success for the user, sys out balance amount, balance deposit success, balance plus equals to amount. In the deposit I'll pass the amount, right? Okay, fine. Here I can print the updated amount, either it will be come or not. This out of updated balance. Updated balance is balance. Suppose once I'll check this. Why? ATM1 withdrawal success. ATM1 try to withdraw by ATM2. Balance amount 1000. Deposit success. Updated balance. Okay. Withdrawal success ATM2. Right. Fine. Yeah, both will become in before. In before, why we don't observe? Because of that. Suppose in before what the statements we are not right. This is the statement, right? This is the statement. This statement we are write it, but it will be in a while loop, right? So one will be, it will be one time it will be execute. Suppose if you observe, it will comes to this. This condition fails means balance greater than amount. This condition fails means user to not try to withdraw the amount. Suppose if you observe, mm, once again I'll run this. If you observe here, try to withdraw by ATM2. At the first try of the ATM2, it will be the success for the ATM2, right? Withdrawal was success for the ATM2 and the updated balance is 1000. Then try to withdraw by ATM1. Try to withdraw by ATM1. Then deposit is success. That means after deposit, updated balance becomes 1000 and withdrawal also success for the ATM2. But why it will not print that updated balance of the statement? Because of it will only in this block. So after that it will be not printed. Why? Because the statement already printed by the what is thread 1. Suppose if I mention this in the control C, in the if block, in the while block, then you can observe after deposit success updated balance, then you can observe the balance amount also, right? Try to withdraw by ATM1. Withdrawal was success for ATM1. Why? Because only 2000 rupees it has to. Then after the balance amount is 1000. Try to withdraw by ATM2. Then deposit is not success. That means withdrawal is not success. Why? Because only 1000 rupees in my account. After completion of the deposit, updated to the 4000. Why? Because 1000 plus 3000. It will be the 4000. Withdrawal was success for the ATM1. What it is? Okay, ATM1 balance amount 2000. Okay, balance amount 2000. Try to withdraw by ATM2, balance amount 2000. Okay. This is the problem. I'll do one thing. Okay. Trying to withdraw by ATM2. Trying to withdraw by ATM2. Withdrawal was success for the ATM2. This statement. Okay, after that balance was updated and the balance will be print. Balance amount will be the 1000. Deposit success and after that update the balance. Try to withdraw by ATM2. Then again withdrawal was success. Withdrawal was success for the what it is ATM2 and after that balance was updated. Again when till to the suppose how many times you can do, that is the way. Okay, fine. That is the thing with the wait and notify. Notify all is also the method. Notify all, what you do is suppose here only you are unlock the one thread, right? Notify all unlocks the all waiting state threads. That is the difference between notify and notify all. Wait is for maintaining one thread into the wait mode. Notify is for releasing the node into the wait state to the normal state. That is the thing. Okay, fine. This is the thing with the multi-threading on the synchronized concepts. And also one term is there, deadlock. Deadlock is there. If you are learn at the OS in the academics, then you can understand that. Or else deadlock is nothing but suppose imagine the thing, thread 1 depends on thread 2, thread 2 depends on thread 1. Okay, thread 1 depends on thread 2, thread 2 depends on thread 1. Thread 2 what it accepts? It will accept the wait or the release state from the thread 1. Thread 2 looking for the release state from the thread 1. Suppose imagine a thing, I have a T1 and T2. T1 is waiting for the release and approve from the T2. T2 is waiting for the release and approve for the T1. That means both are depending on the one each other. Then always they are in the wait state. They are not released. This is comes under the deadlock. For this it will be enough to us. Deadlock is normally you have to understand what the deadlock is. Deadlock is nothing but the threads dependent on each other. It will not yet released at any moment. It will becomes under a deadlock. Okay, right? This is all about that multi-threading and all the concept. Later we are moving to the collection framework. Okay, right? Why this multi-threading is because multi-threading you have to, when you are dealing with the real world problems, then multi-threading is the option to do it. Okay, right? Thank you for this.